Okay, sorry about that, little technical difficulties, but we're back. Okay, we're going to do the same thing again, except this one is not factored for us, so we're going to have to use our factoring skills. This is why I've been pushing the whole factoring quiz thing. By the way, I think I told you guys we were going to do that on Friday, but then I realized we don't have class on Friday. So this is on Canvas as well, but I'm going to offer retakes on that quadratics factoring quiz Friday morning, Friday after school, Monday morning, and Monday after school. So you got 4 different times that you can come in. If you come in before school, come in about 7:20, 7:15. You'll have 15 minutes, same as before. And if you're coming after school, just get here by like 2:20 or something like that. Okay, I'll get folks started right away. If you want to do both, I'm okay with you doing both. Like if you want to do it on Friday, I can grade it really quick and see if you need another one on Monday. And if you take both of them and you're still not happy with your grade, we'll do it again later. You guys can take this thing as many times as you want to. We got to make sure we're good with factoring because of problems like this. So enough of that. Let's get after it. Factor this thing for me. Factor it. Use your skills. Show me your skills. I see a GCF. If you didn't notice that GCF, take care of that first. Uh, 35, that's got to be 7 and 5, right? We need a -2, so I want the 7 to be negative. I'm not picky about what method you use for factoring, and you do not need to show me steps for factoring either. In fact, if you can do it in your head and jump straight to the factors, more power to you. If you really like the Xbox thing and that's working for you, feel free to do that work in your margins, but that's not something I'll be checking. All right, we're factored. So let's start with, what do we want here? Zeros and multiplicity. So let's go ahead and start by making ourselves a little chart here. Zeros and multiplicity. So you'll be doing this on several of your problems on your assignment. I'm seeing 3 distinct factors here, so there will be 3 different zeros, each with their own multiplicity. I'm just going to go in the order that I've got here. This would have a 0 of 0, multiplicity 2. I see a 0 of 7 with a multiplicity of 1. A 0 of -5 with a multiplicity of 1. You don't have to list the x-intercepts and the behavior there if you don't want to, but you're welcome to if it's helpful to you. Since this is our notes, I am going to write what my behavior is underneath this. I probably would not do this on an assignment, but for the sake of our notes, let's talk about whether we're crossing or bouncing. So at 0, we've got an even multiplicity, which means what? Cross or bounce? Even is bounce. And odd multiplicities we're going to cross. All right. Questions so far? You feeling good? Nice thing about this one is we already had standard form, so the next thing I would be thinking about is my end behavior. And since I've already got it in standard form, I don't have to do any of that extra work that we did on the last problem. This is going to tell me what my end behavior is. We've got an even degree, and it's positive. So which dance moves that look like? Even and positive. It's up on the left, up on the right. So my end behavior is going to be up on the left, and then something's going on in the middle, and then up on the right. In your assignment, when we talk about end behavior, I would like you guys to practice using that limit notation. In fact, why don't we go ahead and do that right now, just right underneath this. Make sure you're saving a little bit of space down here for us to do our sketch. But can you write the end behavior using limit notation? Let's practice with that. You'll be expected to do that on our second test. End behavior limit notation always looks the same except for the part after the equal sign. And just as a quick reminder, if x is going to negative infinity, which direction is that? Up, down, left, or right? When you see x is heading in the negative direction, what are you thinking? Up, down, left, or right? So when you see this, I'm hoping you're thinking this is telling me what's going on the left. And what is our graph doing on the left? It's going up to positive infinity, so I should have a positive infinity here. You wouldn't usually write the plus. That's where that's coming from. So on the left, we're going up to positive infinity. And then when x goes to positive infinity, now we're moving to the right. X is heading out towards the positive direction. That's to the right. What are we doing on the right side of our graph? We're also going up to positive infinity. So please practice with that in your assignment when it asks you to find the end behavior. Make sure you're comfortable writing that limit notation. Okay, let's graph this thing. So I'm going to make myself a nice long x-axis here. We'll stick 0 in the middle. And let's get any other important points on this thing. I don't need to make a bunch of tick marks. Let's just make some tick marks for 7 and -5. Just get them on the right general side of the graph. So 7's over here someplace. -5's over here someplace. And we know that we have x-intercepts at those 3 points. So I'm going to go ahead and draw some points there. And we will start by drawing our end behavior. We know it's going to be going up on both sides. And then we just choose one side or the other, and we work our way towards the other side. Last time we went left to right. You want to go right to left this time? Ooh, like you would read a book in, where do you read from right to left? Japanese. Okay, so if you're reading a book in Japanese, we'd be reading this way. And that works. It's fine. It'll work for us. So I'm moving from this. I need to move back towards 7. Am I going to touch or cross? Oh, it looks like I'm crossing over at 7. And then at some point, I'm going to need to curve around and get back up here because I need to be hitting my x-axis at 0. Am I going to be crossing when I do that or bouncing? At 0, it looks like we're bouncing. And then it's going to have to curve back up again to hit the x-axis at -5, and it looks like we're crossing there, which is good because that gets us back where we need to be to join up with our other end behavior. And there's our, and that's when I ask you in the assignment to make a rough sketch, that's what I'm looking for. All right. So far, so good? All right. Let's move on to doing this backwards. So in this case, they've given us some zeros and some multiplicity, and we are going to be tasked with writing the polynomial. Okay? So we got to kind of work backwards. And it says to write a polynomial. It doesn't say what format to write it in, which is nice. I will tell you that in the assignment, they're going to ask for it in standard form, but we're going to start in factored form because if we know zeros, we can write factors, right? So let's start writing this thing. F of x equals, all right, I got a 0 at -6. What's that factor going to look like? If my 0 is -6, what's my factor going to be? X plus 6. Double check that. Imagine if you set this equal to 0 and solved, would you get x equals -6? Absolutely. And what's that multiplicity of 2 going to tell us about that factor x plus 6? It's squared. We're going to have another factor. Ooh, root 5. That's a fun one. Spicy. Root 5. This is a multiplicity of 1. So that would be x. If it's positive root 5, then my factor would be x minus root 5. Multiplicity of 1. So we could write an exponent of 1 on there, but we don't really need it. And then we've got another 0 at negative root 5, so that would be x plus root 5, again, multiplicity of 1. And there we go. If the instructions were just as they are on this page, we'd be done. Except we're going to practice multiplying it out. I have a really important question for you before we do that, though. If I stuck a negative 42 in front of that thing, would it still be a correct answer? So think about this original function. Can you look at this and see, okay, yeah, it's going to be bouncing off the x-axis at -6. It's going to cross at 5 and cross at cross at root 5 and cross at negative root 5. When I multiply it by negative 42, think about what transformation is that accomplishing? The negative is going to make it do what? It's just going to flip over. And the 42 is going to do what to it? It's going to stretch it out away from the x-axis. Is it going to change where it's touching the x-axis? No. So would this still be a correct answer? So how many correct answers are there to this problem? There's an infinite number. We could put any number we want at the front of this thing, because multiplying it by a number, something that doesn't have an x, is only going to accomplish maybe a stretch or a shrink vertically and maybe a flip. But neither of those things are going to change where it crosses the x-axis. We're talking about this now because this is a little bit of a preview of what we're going to be doing on Monday. Monday, you're going to be looking at a graph, and you're going to be using the graph to write the factors. But you're going to have to find the correct number to put out in front. And we'll talk about how we can find that number when we get to that. But for right now, let's just keep it simple and say that's just a coefficient of 1. Okay, now we're going to complicate things because I'm going to change the instructions on you. I want it in standard form. So we're going to need to actually multiply out 4 factors here. Now I'm going to take you through some shortcuts. And I hope that you're familiar with these shortcuts, and if you are not, I hope that you will work to become familiar with them, because we will use them again and again and again this year. Okay? So here's the first shortcut. We've actually talked about this one several times already this year. If I'm squaring a binomial, are you guys comfortable with the shortcut for squaring a binomial? If not, I'm going to run you through it again. You're always going to end up with 3 terms when you're squaring a binomial. Your first and last ones you get by just squaring the 2 things. X squared will be at the beginning, and positive 6 squared is plus 36. That'll be at the end. That's the easy part. It's the middle term that either people leave out or get wrong if they make a mistake. Do you guys remember how to find this middle term? It's the first thing times the last thing and double it. So multiply these 2 things together and multiply it times 2. So x times 6 is 6x times 2 would be 12x, so plus 12x. That's this one that I wrote right here. So square the first thing, square the last thing, multiply them together times 2 in the middle. That's how I remember that one. All right. Do you guys remember this thing? A squared minus b squared, that factors into the difference of squares pattern. Does this look familiar to you? Please say yes, please say yes, yes, yes. All right, good. If not, I need you to know how to factor differences of squares. That's something you can ask me about sometime when we've got some time, or schedule some time after school. We're going to use this shortcut here to simplify our work here, because when I look at this and I see two factors that are exactly the same except one's a plus and one's a minus, that reminds me of the answer when I factor a difference of squares. So we can actually take this and work it backwards. Anytime we see a situation like this, these are called, there's a special name for this that starts with a C. Do you guys remember what that is? We do it a lot with complex numbers, but they don't have to be complex. Complex what? Complex conjugates, if you heard of those. Conjugates, we'll be dealing with those later on. They're super fun. These are conjugates. Conjugates are just, it's two things where one's got a plus and one's got a minus. And when you multiply conjugates together, nice things happen. It's just going to, when we multiply these together, it's just going to be the first thing squared. Always a minus. Always, always a minus. And then whatever that second thing is squared, or b value, which in this case is root 5. What do I get when I square root 5? Just 5. All right, so we've taken 4 factors. When I'm thinking of this as two copies of x plus 6. We've taken 4 factors and we've turned it into 2 factors. Now we just need to multiply these 2 things together and we're home free. Okay. So let's do that last piece here. And I will show you guys my favorite way for multiplying polynomials. Take it or leave it. If I don't do it this way, I make mistakes. I make these little tables. This especially works well if you've got 2 trinomials. And I'm going to put x squared and 12x and 36 across the top. And I'm going to put x squared and negative 5 down the side. And then I'm going to multiply everything out. X squared times x squared is x to the 4th. 12x times x squared is 12x to the 3rd. 36 times x squared. And then I've got a negative 5x squared. And I've got, what would that be, negative 60x. And I've got a negative 180, sound right? And then I can just take that table and do some combining like terms and we'll be all good. X to the 4th, check. X to the 3rd, there's just that one. X squared, I've got 36 minus 5 would be 31x squareds. Minus 60x, minus 180. Yes. This one here? Oh, that's a great question. Why did I write x squared? That's a great question. I don't know. I'm doing that thing where I'm talking and writing at the same time and wires are getting crossed. Thank you. Yes, that should be x to the 4th. Thank you, thank you. Any other slips there? I think the rest is looking pretty good. All right. So you may have some problems where you may end up with 2 trinomials. With 2 trinomials, especially, this thing ends up being nice. A lot of times your like terms are going to end up on a nice diagonal. It didn't happen in this case. But however you go about multiplying is up to you. This just keeps me organized and keeps me from forgetting stuff. Okay, any questions there? What would our end behavior look like for this polynomial? Even degree, positive coefficient, so up on both sides? Yeah? All right. What would the y-intercept be for this thing? What's the y-intercept of this function? Negative 180? And we know where the x-intercepts are, right? -6 root 5 and negative root 5. If I wanted to check this using my calculator, what would be a convenient way to do that? One way I could do it, if I'm fairly confident in this, I could type this in for y1, and I could type this in for y2 in my graphing calculator, and I could look at those two graphs and see if they overlapped each other. Or it might even be more convenient to look at the table and make sure that the columns from your table exactly match each other. So some strategies in case, not in case, when this appears on your chapter 2 test. Okay, last one. This is a button pushing problem, and I'm gonna look one last time for my calculator, but I hope it didn't go missing by nefarious means. That happened once already this year. It's very tempting, bright pink calculator. Well, maybe accidentally borrowed. Let's not accuse anybody of theft. Accidentally borrowed it. You got to watch too. It's a very tempting color. All right. Thank you so much. Thank you. Okay. So this one is asking us to find zeros. Now, this is a third-degree polynomial. At this point, I don't expect you to be able to factor this thing by hand. We will get to that point eventually. But if I ask you to find zeros for this, since we don't have a factored version and we don't yet have the tools for factoring that thing, we're going to have to rely on just graphing it and asking the calculator to find those x-intercepts for us. So let's go into our y equals and get our function typed in. Make sure you're using negatives and minuses appropriately. I know that's kind of annoying. Now, I am not going to hit graph on this thing because I've graphed enough polynomials to know that usually the standard window is not going to show me all the pieces that I want to see. So before I graph it, I'm actually going to have a look at the table. I'm going to look at the y values in the table to see, do I need to adjust my y min and my y max so I'm actually seeing what's going on this thing. So do you guys remember how to get to the table? It's second graph. And I'm just scrolling up to kind of see what's going on the negative end. Ooh, boy, that is getting pretty huge pretty quickly. That would be that end behavior happening right there. You see how those numbers, as I get more and more negative, those y values are getting bigger and bigger and bigger. So I'd say on the left we're going up. And then I'm looking for, what I'm really looking for is like, where do these numbers change from positive to negative? Why is it important for me to be thinking about where the y values change from a positive to a negative? Where it changes from a positive to a negative. Turning point is an x. I want you to keep that in mind next year for calculus, but not turning point in this case. Kind of, maybe. What has to happen on a graph in order for my y value to go from a positive value to a negative value? It's got to cross the x-axis, right? There's going to be an intercept in there someplace. I can look at this and tell you that someplace between -2 and -1 there's an x-intercept because I can see my y value going from a positive to a negative. And then I can also see somewhere between 0 and 1 there's another x-intercept. Can you spot any other x-intercepts on here? I'm seeing a third one now, somewhere between 4 and 5. Are you guys okay with where I'm seeing that? What I'm looking for to find x-intercepts on a table is I'm looking for where the y values switch from a positive to a negative, or a negative to a positive. If I'm switching from a negative to a positive, then somewhere in between there I got to pass through 0. All right, and then really what I'm interested in is like in those areas, like how high up does the graph go and how far down does the graph go? I'm seeing it go down to like -5 there. I'm seeing it going up to like 19. So I think I'm going to adjust my window. Instead of making it go from negative 10 to positive 10, I might make it go from like negative 20 to positive 20. I might even push it a little past there and go like negative 25 to positive 25. I don't know. Let's see what happens. So I'm going to leave my X-min, X-max alone. My Y-min and my Y-max, I'm just going to go from negative 25 to 25. This is an educated guess based off of those Y values that I was seeing in my table. I have no idea if this is going to be a good guess or not, but let's go ahead and graph this. Yeah, that's pretty good. We can see all the peaks and valleys and everything. I'm kind of proud of that. Nailed it on the first try. That doesn't happen often. Okay, this whole like messing around with the window thing is oftentimes you try something and you got to go back and try it again. But I've got a pretty good view of what this looks like. If I asked you to find turning points, you guys would be able to do that at this point. Yes? Okay, well, let me show you the new thing that I want you to be able to do today, which is to find the x-intercepts. So we're going to go to the same place that you would go to find those turning points, those maxes and mins, which is the calculate menu. So go second calc. And if you had to guess which of these options we would be using to find an x-intercept, which do you think it would be? Number 2, right? Because x-intercepts come from zeros. So hit enter, and look down at the bottom of your screen. You're going to see a familiar question. You see left bound down there? You guys remember what left bound meant when we were finding turning points? It meant they wanted us to move the cursor a little bit to the left of the thing we were interested in. I'm going to focus on this left intercept right here. So I'm going to use my arrows to move my cursor a little bit to the left of that intercept. How far to the left? That part's not so important. Just make sure it's a little to the left. Hit enter. Then it's going to ask you for a right bound. So I'm going to move my cursor a little to the right of that intercept. Remember, we're focused on the intercepts, not on the maxes and mins this time. We're focused on those x-axis crossing points. So what I've now done is I've told my calculator, focus in on this one small area of the graph. And then the last question is a guess. It wants me to put the cursor kind of close to where the actual x-intercept is and hit enter. And then it's going to churn and do some fun math. And it's going to give me my coordinates for my x-intercepts. Thank you. Now this is interesting. Are you guys seeing these same numbers on your screen? I think we've talked about this before, but can somebody remind me what 1e negative 12 means? That's 1 times 10 to the negative 12th, right? If you had to write that out with decimals, what would that look like? It would be 0.0000000000001, which is awfully close to what number do you think it's actually trying to say? It's trying to say 0. It's trying to say 0. It's very close to 0. So you will occasionally, your calculator is going to make a small mistake every now and then and give you a number like this instead of 0. That's okay. It did its best. It tried. It got really close. This should be a 0. Okay? The important number here is our x-intercept, negative 1, let's round to, does it say? Round to the 100th. Okay, so negative 1.72, no, we need to round that up to a 3, comma 0. There's one of our x-intercepts. And then we just need to repeat that process and find the other 2. So I'll let you guys go through that process. I'm going to walk through it one more time up here. So I'm going to go second calc 0, and I'm looking for this one over here. So I'll go a little to the left, a little to the right, kind of close to it. And this time it came up with a better value. It actually knows that that's 0. And then I'll let you do the third one on your own, and we'll be done for today. Thank you again. When someone gets that third one, if you could let me know so I could just write it and have my notes complete, I'd appreciate it. What do you got for that third one? 4.47? Thank you. All right. So we're going to hang out on polynomials for a while. The big stuff from today is it's a lot of review from last year. If I show you a bunch of factors, can you turn those factors into zeros for me? And then can you use the exponents on those factors to find multiplicity and use that to guess what's happening on your graph? You guys now know our first pre-calc dance move, the end behavior dance move for polynomials. All right? And we can predict the end behavior, and once we have the end behavior and we can predict what's happening at our x-intercepts, we can make these fun little sketches of what our polynomial graph is going to look like. You're going to have some tedious arithmetic where you're going to have to multiply out a bunch of factors. Go slow, be accurate. Slow is fast when you're doing this kind of stuff. And then the last thing I showed you was how to use our calculators to find x-intercepts on a graph. All right, if you got questions, let me know. I think we got time for me to check your assignment today. Hooray!